Hi guys, how are you all doing today? And it's Jalajor here again, back from BHM at GCSE Chem, back with another video. And today we're going to be doing C1.7 section 1.7 of the GCSE Chemistry AQA Caboodle revision guide or textbook. And yeah, before I start, there was one mistake that I made in the last video, which was C1.6, where I said that the number of protons is equal to the number of neutrons. I said that I put it in the comments as well that I was wrong, but I also wanted to say it in this video that I was wrong, just to let you know. What I meant was the number of protons equals the number of electrons for a neutral atom. You guys probably realized that anyway when you were watching the video, but just wanted to clear any confusion if there was any. But today we're going to be doing C1.7, which is all about ions, atoms, and isotopes. I don't know why I say ions like ions. I mean ions, right? I-O-N-S, right? I've got to get that right. So, what is an ion? So an ion is a charged atom or a group of atoms. So many different ions. There's a chloride ion like Cl-, sodium ion like Na+, but you could also have ions which are made of groups of atoms, like CO3 2- for the carbonate ion, SO4 2- for the sulfate ion. What are the other ones? NH4+ for the ammonium ion. There's so many different examples. So if an atom gains electrons, it becomes a negative ion. By the way, have I shown you this book, by the way? Yep, I haven't shown it again. Like last time I didn't show it at the start. This is the book I'm using, the AQA GCSE Chemistry Revision Guide from Caboodle. Now let's properly start. Sorry about that. So an ion is a charged atom or group of atoms. I've given you many examples just recently now. But, so yeah, Cl-, Na+, SO4 2-, CO3 2-, NH4+, these ones, sorry about the noise there. If an atom gains electrons, it becomes a negative ion. The ion has an overall negative charge because it has more electrons than protons. For example, an oxygen atom gains 2 electrons to form a negative ion, and the formula of the ion is written as O2-. Because it has 2 more electrons than protons, it forms an ion known as O2-. If you have more electrons than protons, it means you have a negative ion. You form a negative ion. Basically, if you have more protons than electrons, it means you form a positive ion. Basically, it means you have a positive ion. And just for your reference, positive ions are known as cations and negative ions are known as anions. Now, if an atom loses electrons, it becomes a positive ion because it has more protons than electrons. For example, lithium ion loses an electron to form the positive ion Li+. That's Li+. So the way you write this as well, I want to show this, is you write the chemical symbol and then you write a plus on top. In case of lithium, Li and then plus. Here O and then 2-. But if you have a 1+ charge or a 1- charge, you don't have to write 1+ or 1-. You can just write minus because that means 1. It's like when you're balancing equations. If there's 1 mole of something, you won't write 1 CO2, you just write CO2. Hopefully you get what I mean there. And how does an atom form a positive ion? So this is a question, and the answer is by losing electrons. It's as simple as that. Now you can represent the atomic number and mass number of an atom like this. So hopefully you can see this here. So this is carbon. Its atomic number is 6 and its mass number is 12. So 6 is at the bottom, 12 is at the top, and in between you have C, which is the element symbol for carbon. And similar thing with sodium, it's just Na is the symbol. So obviously you have 11 is the atomic number, 23 is the mass number, and the symbol is Na. So for sodium, hopefully you can see that. You can represent the atomic and mass number of an atom like this. I've showed you how. This shows an atom of sodium, where they have 23 on the top, 11 on the bottom, and then you have Na, and it has an atomic number of 11 and mass number of 23. Now I made a video about structure of the atom yesterday, which was all about atomic number, mass number. So if you need to revisit that, check that out. Yeah, and then here's another question. An atom of carbon is represented with 12 as the top number, 6 as the bottom number, and then a C. What is the mass number of the carbon atom? Well, remember, mass number is always the top number. It's the number of protons plus the number of neutrons. So here the mass number is 12. So simply, yeah. Now, you cannot see atoms because each individual atom is incredibly small. An atom is about 1/10 of a billion of a meter across. So it's normally written as, an atom is normally 1 times 10 to the minus 10 meters. So it's a 1/10 of a meter, a 1/10 of a 1,000,000,000 of a meter across. So really, really small. Now, I'd recommend you just remember it. Yeah, I don't think they're going to ask you a question on, the size of the atom, but just remember it's 1 times 10 to the minus 10 meters, just for reference, just in case. Atoms of the same element always have the same number of protons, however, they can have different number of neutrons. Different numbers of neutrons. Need to be plural there. And these, atoms of the same element with different numbers of neutrons are called isotopes. Now that's very important. So isotopes are atoms of an element, atoms of the same element with the same number of protons and different numbers of neutrons. Now, if you get a 2-mark question on this, then I think it would be sufficient. Just saying that. But if you get a 3-mark question, you'd probably, it would be better to probably say isotopes are atoms of the same element which have the same number of protons and different numbers of neutrons, and this means that the atomic number, they have the same atomic number but different mass numbers. Adding that extra line, I think, is for that 3rd mark there, just in case you get a 3-mark question. So it really depends how long your isotope definition is. It depends on kind of how many marks the question is. If it's a 2-mark question, it could well be a 1-mark question in which this definition would be, sufficient enough. Even if it's a 2-mark question, I think it would be sufficient. But if it's a 3-mark, you just have to add that thing about atomic number and mass numbers. You just have to add that thing. Now, isotopes of an element have different physical properties, but always have the same chemical properties. Now, that's important. Just remember, isotopes of an element have the same physical properties same chemical properties but different physical properties. And the reason why they have the same chemical properties is because they have the same number of electrons in their outer shell. They have the same electronic arrangement or the electronic configuration, and the number of electrons in the outer shell is basically what determines reactivity, not the number of neutrons. The number of neutrons may be different, but that doesn't affect the chemical reactivity. And that's more of an A-level thing, explaining why isotopes react in the same way chemically, why they have the same chemical properties. That's more of an A-level thing, not required much at GCSE, just for your interest. That's the reason why they have the same chemical properties though. But all you need to know is that they have the same chemical properties but different physical properties. You don't need to be able to reason. Well, by the way, even if they ask you about for the reason, you should, I think, just learn it anyway. It's not in the book, but just in case they ask you why do isotopes have the same chemical properties? Well, that's because they have the same number of electrons, the same in the outer shell as well. So they have the same electronic arrangement or configuration, meaning that they react in the same way chemically, same chemical properties. Now, question number 3 here is obviously 2 isotopes of hydrogen are, hydrogen 1 and hydrogen 2. So that's basically with with mass numbers of 1 and 2 respectively. What is the difference between the 2 isotopes? Well, obviously the one with the mass number of 1, that's known as a normal hydrogen. That has 0 neutrons, whereas deuterium, it's called, actually, the other one. The one with mass number 2 is called deuterium. The one with mass number 1, we just normally refer to it as normal hydrogen, but the one with mass number 2 is known as deuterium, and that has 1 proton and 1 neutron. So obviously it has 1 neutron. Deuterium has 1 neutron, whereas the one normal hydrogen with atomic mass or mass number 1 has 0 neutrons. So hopefully that's clear. When dealing, so that's the difference. So by the way, if you're following on, it's pages 16 to 17 of the student book. Should have probably said that before, but there we go. Standard form and nanometers. So that's kind of the last big section of the book. Of the section. Well, I don't know what I'm saying, but let's move on. When dealing with very large or very small numbers, you can use powers of 10 to express a number. For example, 1 million meters is 1 times 10 to the power of 6 meters. 1 millionth of a meter is the same as 1 times, or is written as 1 times 10 to the minus 6 meters. See the difference in what I said. 1 million meters is 1 times 10 to the power of 6 meters, but 1 millionth of a meter is the same as saying 1 divided by a million meters, which is the same as saying, or writing 1 times 10 to the minus 6 meters. And another useful unit when we describe size of atoms is nanometers. So nanometers, which are nm, is the kind of short form, we use nm, are used when describing the size of atoms, where 1 nanometer is 1 times 10 to the minus 9 meters. And therefore it follows that 1 meter is 1 times 10 to the 9, 1 times 10 to the power of 9 meters, but nanometers. But there we go. Just remember, really, 1 nanometer is 1 times 10 to the minus 9 meters. But then obviously you know that 1 meter is 1 times 10 to the power of 9 meters. So 1 times 10 to the power of 9 meters is what? Wait. Sorry about that. Nanometers. Okay, I'm not going to say that. I don't want to confuse anyone. Nanometers are used when describing the size of atoms, where 1 nanometer is 1 times 10 to the minus 9 meters. And if you had 1 meter, that would be the same as saying 1 meter is the same as 1 times 10 to the power of 9 nanometers. There we go. Finally got myself right. I don't know what I was saying in the last few seconds there. Hopefully that makes sense. Keywords are ion, isotope. And also atoms are quite important there as well. And a synoptic link, was it synoptic link? Whatever, synoptic link. For more information about formation of ions from atoms, see topic C3.2, which we will get to in chapter 3. So now the key points, just to finish off, are that atoms that gain electrons form negative ions. If the atoms lose electrons, they form positive ions, and remember, positive ions are known as cations and negative ions are known as anions. You can remember the atomic number and mass number of an atom using the notation. For example, for magnesium, you'd have 12 is the atomic number, 24 is the mass number, so you'd have 12 on the bottom, 24 on the top. And then Mg, where magnesium's atomic number is 12 and the mass number is 24. Isotopes and the final point is isotopes are atoms of the same element with different numbers of neutrons. They have identical chemical properties, but the physical properties, such as density, can differ from each other. Can differ. Just say can differ. And yeah, hopefully this was very useful, guys, for you. And just to clear up, because I know I waffled a bit. In the when I was talking about nanometers, just to really make that clear, 1 nanometer is 1 times 10 to the minus 9 meters, but 1 meter is the same as 1 times 10 to the power of 9 nanometers. So I really hope that's clear, and I'm really sorry that I didn't make that clear if you got confused before. If you found this video helpful, make sure to share, like and subscribe, or just share, like and subscribe, and I'll see you in the next video, where the last section is now 1.8 C1.8 electronic structure. Then we've finished the first chapter, so that's good. And yeah, I think I'll go now, and make sure to turn the notification bell on if you haven't done already, so you know when I upload new videos. Thank you very much, guys, that you can watch obviously the video.